EDX Mechanics 1, collisions in one dimension, successive impacts of spheres. So we've seen the coefficient of restitution, which measures the elasticity of a collision and is a property of the combination of the two materials, so where E equals the separation speed divided by the approach speed. And we've looked at kinetic energy, and this is considered for all objects together and is usually lost as heat or sound during the collision. Kinetic energy is a scalar quantity, and a negative answer would indicate a kinetic energy loss. Changing kinetic energy is taken as the final kinetic, take away the initial kinetic energy. So here, initially we have three objects. They are moving as shown when A collides with B and then B collides with C. We need to show there are no further collisions after those two collisions and that we need to find the kinetic energy lost. So we need to be given some information. I'll give you extra information as we are going along. So looking at the first collision. So in this first collision, we're told that E equals a half, and we are told that A will move off at 3 meters per second. We need to find out the velocity with which B will move off. So the first thing I want to do is Newton's law of restitution with A and B colliding. So E, which is a half, is the separation speed. Now if A and B are moving to the right, then B must be leaving A at a higher speed, so U is bigger than 3. So the relative separation speed between them is the bigger U take away the smaller 3. Before the collision, they're both moving to the right. A's moving at 7, B's moving at 3. So the approach speed for the collision is the bigger 7, take away the smaller 3. So that gives me U take away 3 is 2. U equals 5 meters per second. So that 5 meters per second is going to be the velocity of B when it now hits C. So I'm going to draw a new diagram now, and the new diagram is now showing B moving at 5 meters per second and having a collision with C. I don't know the velocity of C after the collision, so I'm going to call it V to the right. So now when I do Newton's law of restitution, and this is B hitting C, the coefficient of restitution is given as a half, and the separation speed, again both arrows to the right, V must be bigger than 4 after the collision, C must be travelling faster than B, so it's the bigger V take away the smaller 4, and before the collision the approach speed, they're both moving to the right, so the approach speed is the bigger 5 take away the smaller 3 as they approach each other. That gives me V minus 4 equals 1, and therefore V equals 5 meters per second. So we know that C will now be moving at 5 meters per second away from B. Now this diagram shows the original velocities of 7, 3 and 3, and we now have all the final velocities 3, 4 and 5. So now we want to find the kinetic energy change. So that's the final kinetic energy first. So we've got a half, 1 kilogram moving at 3, and we've got a half, 2 kilograms moving at 4, and we've got a half, 1 kilogram moving at 5. That's the final kinetic energy. Take off the initial kinetic energy. So half, 1 kilogram moving at 7, plus a half, 2 kilograms moving at 3, plus a half, 1 kilogram moving at 3. So final kinetic energy, take away initial kinetic energy, gives me minus 5 joules. So the kinetic energy change is minus 5 joules, or we can say the kinetic energy lost, which is what the question wanted, is 5 joules. So the change is minus 5 joules, the loss is 5 joules has been lost. So be careful whether you're talking about kinetic energy change or the kinetic energy that has been lost. In the next session, we're going to be looking at successive impacts with a smooth plane.